Good afternoon, friend. Myself, Chandra Kumar. I am taking a lecture on electrical machines. In continuation of the previous lecture, now we are discussing about the modern machine manufacturing techniques. Under this, we are already discussing all the general concepts, major consideration in the design of electrical machine. Now we are discussing all the electrical engineering materials. And if with this lecture we continue of the previous lecture, and over here we are just discussing all the properties of the material and which property is most important while we are just discussing about the manufacturing of the machine. There will be first type of material is the high conductivity material. High conductivity material means a material which having the high conduction capacity is there. So it will be used for making of all types of machines windings, or it can be used for the all types of operators and devices manufacturing, used for transmission and distribution of electrical energy from one position to the another distance. If the distance is more than a limit, then it will be comes under the transmission, and if it will be comes under a lower rating of lower distances, like the 50 kilometer or 100 kilometer, then it will come under the distribution. So distribution and transmission of electrical energy from one point to the another one, it will be, we are using a high conductivity material. There must be the least possible resistivity, means it will offer a low resistance against the flow of the current. Next type of material is the high resistivity material, and this type of material conductivity, obviously it will offer a least conductivity material or a high resistivity materials are this. They are used for making of the resistances. They can use for making of heating devices. Heating devices means just like a electrodes we are using for that, and we are using the heater just for making the this one. The fundamental requirement for the high conductivity is that there must be a highest possible conductivity is there. There must be least possible temperature coefficient of resistance. Least possible temperature coefficient of resistance is the resistance offered against the temperature, it will be least. There must be a high mechanical strength, high tensile strength, and absence of brittleness. That the material is never a brittle in nature. Material must be rollability and the durability. Rollability means we can roll the material and convert, or durability converting a different shapes, whatever shapes we are required. It can be weldability, means it can be easily weldable in nature, and it will be solderable in nature. Adequate resistance to corrosion. That it must be anti-corrosion in nature. Properties of the of such type of material, there is a resistivity. Properties which will be related to a material, there must be a resistivity, specific weight of the material, density, resistance, temperature coefficient, coefficient of thermal expansion, thermal conductivity, specific heat, and the tensile strength. These are the different properties which will be associated with the material while we have to selecting any kind of material for any types of electrical purposes applications. There will be the copper property. There is the one material which we are using for the winding, and most commonly we are offering this one, it will be a copper. And the properties of the copper is that it has the high electrical conductivity, having the excellent mechanical properties. It will immunity from oxidation and the corrosion, highly malleable in nature, ductile material, can be forged, rolled, drawn, and machined. Most electrical machines employ windings of annealed high conductivity materials. Hard drawn copper wire used in electrical machines as a wire. Then another material is the aluminum, and its properties is aluminum is available in abundance on Earth's surface. It will be softer than the copper, cannot be drawn into fine wires due to low mechanical strength. Machines have to be redesigned for larger slots to accommodate aluminum wire. For induction motors with power output up to 100 kilowatt Aluminium can be used as bars and spiral cage. Super enamel aluminium was used as stator windings of small induction motors. Aluminium also used as transformer tank because of its light in weight. These are the comparison with the copper and the aluminium because both material can be used for the machine purposes for designing of electrical machine. As compared to the cost, copper, if we are saying that it will be 1 unit, then the aluminium it will be 0.49. Cross-section point of view, copper is 1, aluminum is 1.62. Diameter point of view, copper is 1, aluminum is 1.27. Volume-wise, copper is 1, aluminum is 2.04. Weight, copper is 1, aluminum is 0.49. Breaking strength, copper is 1, though aluminum is 0.4. So it will be the PC per unit price by weight of copper and unit price by weight of aluminum. According to the characteristics, density of the copper is 8900 and the aluminum it will be 2700. Melting point in degrees Celsius, copper can withstand up to the 1083 degrees Celsius, aluminum can withstand up to the 660 degrees Celsius. Thermal conductivity, it will be 350, aluminum will be 200. Resistivity it will be in 10 to the power minus 6, 0.01724 times 10 to the power minus 6. Aluminum is 0.0287. Resistance temperature coefficient at 20 degrees Celsius or minus 1 degree Celsius, it will be 0.00393 and aluminum it will be 0.0039. Coefficient of thermal expansion at 20 degrees Celsius per degree Celsius, it will be 16.7 into 10 to the power minus 6 and aluminum it will be 25.5 into 10 to the power minus 6. The specific heat of the copper is 390, but aluminum having nothing will be given. Specific strength, it will be 220 by 250, but aluminum having a 920. So this will be the foil type winding. A new development in transformer manufacturing is use of foil type windings are there. This is because aluminum can be rolled to thinner and more flexible sheets than copper. Foil type windings are often used for low voltage winding of small and medium rated transformers. And this will be the structure of the machine which we are using for making the foil type winding. Now this will be the end of the lecture. Thank you for attending the lecture, and if anybody you can discuss.